Good afternoon. I'm going to tell you something about the design and development of a multifunction device for lead-acid batteries we developed by our department at Tomáš Bata University in Zlín. Let me start with short presentation overview. I have here some questions just to answer why device for lead acid batteries. Maybe it's old-fashioned because the batteries here used mostly are Li-ion, but it's not completely true. Why multifunctional? That means if there are more functions, it's better. We can save space and so on. Then I will tell you something about what does the device do, or maybe what it doesn't do, what it can't do. I will mention the device structure, how is it done, what is conclude, and then I will talk something about verification of these functions by practical measuring. And also I will mention what does it include about the price, how much does it cost, the device itself, and also what are the costs for the energy we will see later. Also, I will mention future plans and then I will conclude. So why device for lead acid batteries? Lead acid batteries are still widely used in automotive industry, not only there, also in battery storage systems. The reasons are like that the batteries are relatively inexpensive, they are cheap, and other reason is that we can recycle it almost 100%. That's perfect because no environmental impact. For example, lithium-based batteries are recycled at this time only about 5%. Lead acid batteries are not dead. That means that this technology is still advancing. Some known companies still try to find better batteries with better parameters. Here are some examples: sealed tubular gel batteries, advanced lead carbon batteries. So still there is an advance. And also future market insight predicts that the number of lead acid batteries will even increase. That means that the market still will have the demand for these batteries. Now, why our device is multifunction? So, if you have some device which can share some function blocks, it's better because you don't need to produce individual devices which only one function, single purpose devices. So you will save some sources. That means you can use only, for example, one microcomputer which will drive a few devices, or only one device if you have multifunction device. Also, the price for such device will be lower if you compare it to number of single purpose devices. So it's better to produce one device which is able to do more functions. And also you will save the environment because you don't need to transfer these devices, you don't need to store these devices. So again, it's better. So we will save other resources, energy, occupied land, because you don't need to use such as storage areas and so. So now let's move to device itself. The main function of this device is to extend the life of accumulators by restoring their capacity. The main problem of lead acid batteries or accumulators is that if they are not kept by the full charged state, they lost its capacity. That means if you have like only 20% or 30% charged battery, it lost some part of capacity by sulfation. And the device is able to remove such a sulfation. It uses some high frequency pulses and to get the accumulators to its full capacity, or at least to some higher capacity. Especially if you have new cars which use lead exit batteries, they have some charging which actually allows quite deep discharge of these batteries to save the energy for the fuel. They don't charge the batteries all time. They use charging when the car is braking by its engine from the hole when it's doing downhill. So in these cases, it can happen quite easily that these accumulators will get to state which is quite undercharged. The device is able to measure the storage capacity of the accumulator. Also, as I mentioned, it can the regeneration, this capacity. Also, it can restore the capacity verification by the repeated capacity measurements. That means you can compare the capacity before applying this device and after applying this device. And then you can immediately see what was the result and if this recovery was successful. This device has also some other functions. These other functions are like you can use this device as a voltmeter, ampere meter. Also, it can serve as stabilized voltage or current power source. Also, it's possible to put some frequency pulses, so it has frequency pulse generator and others. So this device can be used not only for this main purpose, but also for some other things which can be useful for example, testing some devices and so on. What is the device not able to do? Like, as I said, the battery can be recovered, or the capacity of the battery can be recovered. But in fact, if the battery is damaged, that means that the plates of the batteries are physically damaged, or the plates are shorted. In this case, of course, it's not possible to use or to recover the capacity of the battery, but no other methods could recover it. So that's the state which is quite common. It can't do miracles. Also, the device is not able to identify the original battery parameters. So if you don't know the original capacity, that means, for example, the battery can be produced with 60 ampere hours or 80 or 100 ampere hours. This device can't find the value. It can only find the value of the actual capacity. That means you will measure that it has like 50 ampere hours. After the recovery cycle, you can find that it has, for example, 60 or 70 ampere hours. So it gets some improvement, but you are not able to find the original parameters. In this case, you need, or the operator must define the parameters of the battery itself. So you need to put some input to the battery, and then the device can set, based on these input parameters, the optimal current or optimal recovery cycle to get back the maximum of the capacity. The structure of device, the device is actually driven by a microcomputer and includes some other modules. It has automatic unattended capacity measurement, so you can just put the battery to the device and the device will say what's the actual capacity, how many ampere hours that capacity is. Then it can regenerate the capacity. That means using the high frequency pulses, it can improve the capacity. Also, there must be some other supporting devices, modules, sorry, like charging module, voltage put generator, voltmeter, ammeter, and so, because you need to know the actual state of the current and voltage and so on. And there are also some other like parameters or modules which are not only for the main function, as I mentioned. Here you can see the structure, like there is a microcomputer, and to the microcomputer are connected the individual modules which serve for the function I mentioned. I know we'll just mention one of these modules because it's quite a lot of modules. So for example, the desulfation, which is the base or the main function of the device, which communicates with microcomputer. Here is for example, part of the schematic connection. Yeah, there is some step-up converter because it put the higher voltage than this, the nominal value. Like if you have nominal value like 12 volts accumulator, to get the recovery, you need to use pulses with a voltage about 60 till 80 volts, so it's much higher. So there must be step-up converter, and also you need to, or you may, to influence the width of the pulse or the frequency of the pulse, so you can change the energy which is going to the accumulator. Here you can see the structure of the device. So for example, here's a printed board with the individual elements. And something about the verification. So we measured the results with real accumulators. So we tried how it works or not. So at first you need to have charged battery because you need to measure the original, the first capacity of the battery. Then you need to desulfate the regeneration cycle to put to the battery. And after that, you will measure the capacity again just to find what was the result, if it was better or if it stayed the same or whatever. And here is one of the examples we measured. So here you can see before the sulfatation, the capacity of used accumulator was only less than 20 ampere hours. After the sulfatation, we got 28, almost 29 ampere hours. So the renewed capacity was about almost 10 ampere hours. It's not so bad results because we used really old batteries we got for free. And just to see some percents, we got increase at 47% from the original initial capacity. So this device, which was developed, cost us about 250 euros. So it's quite a lot. But the problem was that the designed circuits must be changed because it was really a problem to get any parts. This was situation with COVID-19. No microcomputer was possible to get the original we wanted. No other devices. So we have to rebuild the device a few times. And it, of course, cost a higher price. What about the regeneration cost? Because you need some electric energy to recover the battery. So if we just use some unit price for 1 kilowatt hour, let's say that we will take about €0.25 for 1 kilowatt hours. For the battery we mentioned, we needed about 311. That's less watt hours. That's less than 1 kilowatt hour. So it means that the whole recovery was about less than €1. So it's not such much for the electricity. So what about future plans? We would like to put there some other functions to the device, like not only lead acid batteries, but also any nickel cadmium or lithium batteries or something else. Also, always is possible to improve the software of this device. And we are thinking also about using the RFID chips, which could say what was the original capacity of the batteries. Then the device could read the value from the RFID. So the operator couldn't put there the values, couldn't know the values which were from the manufacturer. I will conclude with the statement that this device is already patented, and also we are in the process of commercialization. So we will see how it will finish or what will be the practical result for this. So thank you for your attention. That's all.